All right, so we just looked at the unanimity rule where before an option can be chosen or a choice can be made concerning a particular economic voting or political voting, all the members or all the people that are affected by that particular policy uh, must come into agreement. But we saw the limitations, how difficult it is to bring all these people together, the decision making cost and all those things that you have to care before we, we reach an optimal outcome. So today we will look at the majority voting rule. Okay, the majority voting. So as I was saying, the unanimity rule is very difficult to attain. You need to bring all those people together before you are able to uh, get the required or the particular policy that you want to vote for. And because of the difficulty in getting this particular choice, we need to adopt other systems of voting that do not require the unanimity uh, decision making. So one of these systems of voting is the majority voting rule. The majority voting. So if elections are being done on the basis of majority voting rule, then here we just need more than half of the voters to vote in favor of that particular policy for it to be enacted or approved. So if 100 people are voting for that particular policy and 51 people vote for or they vote in favor of that policy, then the policy uh, implemented. So that is basically the majority voting rule. Now let's look at an example of this voting system. Now we consider a community where we have three voters. We have Kofi Ama and then Jao, and then the options or the policies that they need to choose from are policies A, B, and then C. Now, when you go for policy A requires only a small budget, just a small amount of money. The policy B is for a moderate budget, so I mean a moderate amount of money. Then level C goes for a very large budget. So you need much money before you can enact policy C. So let's look at how the majority voting rule can be used to determine which particular policy or level we have to go for. Now, this table that we see here is showing the preferences of these voters, the individuals that are affected by this policy. So if you take the first column is talking about the choices, okay, the choices. So if you see the policy on the first row here, then that's the first choice for that particular individual. If it's on the second row, that is the second choice for that particular individual. And then the third row is for the third choice as well. So if you take Kofi, what this means is that Kofi prefers level A or policy A to policy B, and he prefers B to C. Okay, and then if you go to Ama prefers C to B and also prefers B to A. And if you take Yao prefers B to C and prefers C to A. One thing we need to understand here is that the individual's preferences are logically consistent. They follow the axiom of transitivity. So if you prefer A to B and you prefer B to C, then you must prefer A to C. Okay, so this table is revealing the preferences of these individual voters. Now, let's suppose that we are holding an election between policy A or policy B. Let's go back to the table and then see which policy these three individuals will vote for. Now, if you take Kofi, the policy is between A and then B. Okay. If you take Kofi, you see that policy A is on the first row for Kofi before B. This means that Kofi will prefer policy A to policy B. So if we are talking about Kofi with a voting between A and then B, then Kofi is going for A. So we've gotten one person voting for A over B. If you take Ama, then B comes before A. B comes before A. So Ama will be going for B. Ama will be going for B. And then if you take Yao, Yao, B comes before A. So Yao will also be going for B. Okay. So what we see here is that when we conduct a voting between policy A and then policy B, Kofi goes for A, Ama goes for B, and then Yao will go for Yao will also go for B. And Yao will also go for B. So now, if you look at this, then a voting between A and B means that B is winning. B is getting 2 votes, and then A is getting what? Is getting only 1 vote. Ama and Ya will be voting for B. So any election that will be conducted between A and B based on the preferences that we have in table 1, then policy B is going to win. Now let's look at what happens if we conduct an election between B and then C. Let's look at B and then C. If an election is conducted between B and C, Kofi is going for B because B comes before C. Then Ama will rather go for C, and Ya will go for B because for Ya's preference, B comes before C. So if you look at this, we are getting 2 Bs and then 1 C, which means that when an election is conducted between policy B and C, then policy B is winning as well. So what are we saying here? If an election is conducted between A and B, B is winning. If it's conducted between B and C, B is winning, which means that it doesn't matter which pairs of election, which pairwise election we do, B is always winning. So what this means is that based on the majority rule, B is going to be approved. Okay, B is going to be approved. So when an election is conducted and only these 3 people are voting based on the preferences that were revealed in table 1, then B is winning against A, B is winning against C as well. So based on the majority voting rule, level B or the policy B is going to be selected since it wins against both the other policies. Okay, so that's an example of how the majority voting rule is adopted. Here, we're lucky, we're able to just get the desired outcome. We've been able to get to a decision very easily, but it's not always like that. Okay, we wouldn't always easily get the outcome. At times, it becomes time consuming. It takes time before we are even able to get an outcome. There have been cases where it is not even possible for us to get an outcome. Okay. So now let's take another example. We are still using the 3 policies, A, B, and C, and then Kofi Yao, and then Ama. Now we will be doing the pairwise elections. When we talk about pairwise elections, we are just talking about elections that are being held between any 2 alternatives, any 2 policies. Whenever we have more than 2 alternatives that we can always vote for. So for this case, the alternatives are A, B, and C, but then we just do pairwise election between either A and B, either or B and C, or A and then C. So whenever we see pairwise election, that is what it means. Now let's look at the table 2 with different preferences. Okay, these preferences are a bit different from the first one. Now, if you take Kofi, Kofi prefers A to B and prefers B to C. Ama prefers C to A and then A to B. Ya prefers B to C and C to A. So now let's see if we conduct pairwise election, are we actually going to land in an equilibrium condition? Let's do election between A and B. If we do it between A and B, Kofi is going for A, Ama is going for A, and then Yao is going for B, which means that here A is winning. So between A and B, we'll go for A. Now, what if we do between B and C? B and C. For B and C, Kofi will go for B, Ama will go for C, and then you will go for B. So you see that between B and C, B is winning. Let's not forget between A and B, A won. And now between B and C, B is winning. What about A and then C? Between A and C, Kofi is going for A, Ama is going for C, Yao is also going for what? Going for C. So what is happening here? You see that A was preferred to B. When we held an election, a pairwise election between A and B, A won. And then between B and then C, B won. Okay, so B is preferred to C. So based on the law of transitivity, A must be preferred to C. But that is not what we are seeing here. An election between A and C, we saw that C is rather winning. C is rather greater than A. Okay, so here we are not getting any equilibrium. There's no outcome. This gives rise to the voting paradox. Okay, so if this is the case, we can continue voting and voting and voting. We'll never get any equilibrium point. Okay, we'll never get any. So if you compare these preferences to the first one, you see that there are differences in these two. The first one, we were lucky, we easily got the equilibrium point, but then for this set of preferences, we were not able to do so. Okay, so as I was saying, well, some of the preferences, like the set that we just looked at, the one in the table 2, it wasn't logically consistent. Okay, A is preferred to B, B is preferred to C, but then C is rather preferred to A, which was supposed to be otherwise. If you take the individual preferences, those ones are consistent. They are logically consistent. But I mean, if you take the entire community, if you take the entire people that are engaged in the voting process, you see that their preferences are not. So when the individual voters have consistent preferences, but then the entire community has inconsistent preferences, then that's a phenomenon that we call the voting paradox. Okay, the voting paradox. All right, so now when we have the voting paradox, like what happened in table 2, okay, now we are unable to get the ultimate outcome. But before we can get that, it normally depends on the order of the voting. Okay, it depends on the order of the voting. The pairwise elections, how are they ordered? Before we can actually get the ultimate outcome, we have to pay much attention to how we order the election. Let's see one order. Assuming that initially the first pairwise election was held between A and B. Okay, so after A and B, we just pick out the winner, and then the winner faces C. Okay, then the option that wins there becomes the ultimate choice. So in this case, when the election was conducted between A and B, the winner was A, right? The winner was A. So if the winner was A, then we run A with C. So if C wins, then we go for C. If A wins, then we go for A. So first we pick one pairwise election, and then the winner that we get there, we run an election between that winner and then the remaining choice or option. Okay. Now, the table there, if we first use a pairwise election between A and B, A wins. So A will now face C. And we saw that when we held an election between A and C, C won. So if this is the order of the voting, that A goes with B, then the winner faces C, then C is going to be the ultimate choice. Okay, so you see how the order matters. Let's look at another order. Assuming that the first election was held between B and C, that one B will win. Okay, if you remember, B won. And if B is then run against A, then A wins. Remember, election between A and B, A wins. So here, A is rather the chosen policy. You see, so when first the election was between A and B, C is winning. Now, if it's between B and C as the first election, then A is win. That's why we are saying that when it happens like this, if you have the paradox, then the ultimate choice will crucially depend on the order of the election. Okay, it will depend on the order of the election. So here, before we under the majority voting rule, before we can actually get the, assuming we don't have the what we call a single peak preferences, where we are able to get an outcome, an ultimate outcome just after one round of election. Then when we face the voting paradox, then if we are able to control the order of the voting, it has a very significant impact on the outcome of the election. Okay, so we need to be able to order the elections before we can actually get the ultimate choice. Okay. Now, the issue is that if we don't have those preferences, that will easily result in an ultimate outcome. The voting can go on forever, because you see that A will be preferred to B, B will be preferred to C, C will be preferred to, you have to be going over and over and over. Okay, and that will never end. So the pairwise election, it's possible that there will be no political equilibrium. Okay, what it means is that there's no way one particular choice will be able to defeat all the other options or policies that we are considering. Okay, that we are considering. So that is one major challenge with the majority voting. Now, the case where the voting will keep on going and going is what we call the cycle. Okay, so the voting will keep on going just because we are not getting any particular choice that overpowers or overshadows all the other alternatives that we are considering. But now the question is that what gives rise to the voting paradox? What causes this? Okay, it's because of how the individual preferences are structured. Okay, now we like the example that we saw, the options were A, B, and C. Okay, so how are the individuals revealing their preferences? What is the structure of their preferences? Okay. Now, if you take the first table that we saw, the first table, all the individuals were having something we call the single peaked preferences. Single peaked preferences. But the second table, Amma was having a double peaked preference. We will look at what those things are. So whenever, even if you have just one individual, one voter, having a double peaked preference, then you have the voting paradox. Okay. Now, this is how we draw the diagram. We have the utility on the vertical. The utility is just talking about if the person prefers A to B, it means that option A gives the person a higher utility than B. Okay, so this is for the utility, and then this is for the options on the table. Now, if you take Kofi, okay, we are looking at the second table. If you take Kofi, Kofi preferred, these are the options, option A, B, and C. Kofi preferred A to B, which means that A will give him a higher utility than B. You see, that's why the preference is falling, the utility level is falling as we will move from A to B. And then he preferred B to C. So from B to C, there's a fall in utility there. That is for Kofi. And then if you take Yao, okay, if you take Yao, Yao preferred B to A. He preferred B to A, and then he also preferred B to C. I wish we could get the table here. All right, so this is for Kofi, this is for Ama, this is for Yao. And then for Kofi was A, B, C. Okay, this was a preference for Kofi, and Amma was C, A, and then B. And then for Yao, Yao was B, C, and then A. Okay, B, C, and then A. So now, if you take Yao, Yao prefers B to C. So you see that B is higher than C. And then also prefers B to A. So you see that B is also higher than A. So, I mean, when you are drawing the preference between C and A, the C, the utility for C can be a bit higher. Okay, that one should be higher than that of A, just to show that he as well prefers C to A. Okay, let's look at Amma. Amma preferred A to B. So you see that the utility from A is higher than that of B. Okay, and he also preferred C to A. So look at where C is. C is greater than A, and then C is also greater than B. So C is greater than A. The utility from C is greater than A, is also greater than B. So these are the preferences as depicted by the table that we have there. Now, when we talk about the single peak and then the double peak preferences, if you have a single peak preference, something like Yao and then Kofi, as soon as you move from that ultimate choice, that's your first choice, it doesn't matter the direction that you move to, the utility that you get from the other choices must decrease. So if you take Kofi, A was the option with the highest utility. So from there, okay, from here, we see that Kofi preferred A to all the others. So from here, as he started moving down, he didn't come up again. There was no increase in utility. The utility was just decreasing until he got to C. If you take Yao, okay, if you take Yao, Yao preferred, he mostly preferred B. So B was the highest choice for Yao. So if you move from this B and you try to go right to C, you see that there's a reduction in utility. If you move to left, so you are going to A, that one too, there's a reduction in utility. For Yao, we could move in both sides, but for Kofi, it was just one side. Nonetheless, whenever you move from that peak, you see that there's a reduction in the person's utility. So these are preferences with single peak. The preferences are single peaked. So Kofi has a single peak preference because as he moves from A, there's always a reduction in utility. Yao also, the preference for Yao is also single peak, but when he moves from his ultimate choice, there's always a reduction in utility. But if you take Amma, when you stand at A is C. If you stand at C, C is one peak. If you move to the left, there's a reduction in utility up to point B. But then if you move again, you see that there's an increase in utility. So the utility is falling and increasing again. So this one to point A is another peak. If you come and stand at A, if you move down like this to B, you see that there's a reduction. But you move up to C and then you see that there's an increase in utility. So despite the fact that Kofi has a single peak preference, Yao also has a single peak preference. Amma is having a double peak preference. And this is the reason why we are getting the voting paradox. Okay, if you take the first table, when you draw this diagram for the first table, you realize that their preferences were all single peak. Amma's preference was also single peak. For the first table, Amma preferred B to C and then C to A. Okay, so let's try and draw that one and see. Amma preferred first one, he preferred B to C. B to C. So B is here. So he preferred B to C. Okay. And then if you move from and then from B and then A to, he preferred B to A. Okay, but then he preferred C to A, so we can do this. C must be up a bit more than A. Okay, my mouse isn't good. So here too, we see that Amma will be having a single pick, just like Yao, and then Kofi. So if it happens like this, then we are able to get the ultimate choice, or the ultimate outcome. But whenever the preferences are double picked, then we enter into the voting. So this is the definition for the peak. The peak in the individual's preference is just the point at which all the neighboring points are lower. So if you take A and A is the peak, then if you move to B, B should be lower. If you move to C, C should be lower than A. So a voter is said to have a single peak preference if, as he or she moves away from his or her most preferred outcome in any and all direction, his or her utility consistently falls. So that is for single peak, like Yao. If he moves here, there's a fall in utility. If he moves here, there's a fall in utility. And then Kofi too, as he moves from here, there's a fall in utility. But then for the double peak, if the person moves away from the most preferred outcome and utility goes down, but then goes up again, like the case for Amma, it goes down and then goes up, or it goes down and goes up. So that is a double peak preference that we have. So as I said, Kofi and Yao were having single peak, but Amma was having a double peak. That is why we're having the voting parameters. So assuming Amma also had preferences that were single peak, then you get, I mean, an ultimate outcome without encountering the voting paradox. Okay. So for us to prevent the voting paradox, we need to make sure that all the voters are having single peak preferences. Okay. All right. Now, rules by which winning votes are determined. Okay, how are winning votes determined? We have the simple majority. For the simple majority, if an election is being conducted on this rule, then each and every voter has only one vote. Okay, and then you just need the choice of the policy or the option. Just needs simple majority. Just get a simple majority, more than 50%, you have won. Then for qualified majority, you need at least 2/3 of the vote before you can win. Okay, you need 2/3. So like 66.7 voting. That should qualify you to be the winner, or qualify the policy to be the winner. And then the minority rule, that one you need less than 50% of the votes to win. You need less than 50%. So here the disadvantage attached to the minority rule is that if you go for the minority rule, then it's like the policies that are going to be enacted will be in favor of just a small group of people, and then a lot of the voters will dislike the policy. Okay, and in cases like this, the majority people that didn't vote for that policy will be incurring higher external costs. Okay, higher external costs. But the argument in favor of the minority rule, the argument in favor of the minority voting rule is that the cost of the decision making is less. Okay, the cost of decision making is like we don't even need much time and much resources before we can actually get a winner. We just the smaller percentage should rather win. Okay, so it's not like the unanimity rule where you have to get all the people to come together to give their consent before you go for a policy. Okay. All right, so this is the decision rules spectrum. Now, if we are going for assuming n number of people are voting for the policies, okay, for the unanimity rule, you need all the n people to come together to come into agreement. But for qualified majority, you need 2/3 of the voters. For simple majority, you just need 50% and then at least one vote. Then for the minority rule, anything lower than 50% should land you into the winning box. Okay, so this is the spectrum for the various voting rules. Now let's look at cost of social choice process. Now, when we are participating in social decision making, when we are voting, what are the costs that we get? Now, if you take the unanimity rule, okay, there is no external cost at all, because there's no external cost because all the people are coming together. The external cost just talks about the cost that a voter will have to incur because of the decisions of the other voters. Now, maybe because of the choices that they made, I didn't like those choices. I will have to bear whatever consequences of their choices. But for the unanimity rule, we have all come together to agree. So, I mean, there's no external cost at all. Okay, there's no external cost at all. But if you take the other voting rules, now maybe I voted against whatever option that won, and I wasn't happy about it. I have to live with my dissatisfaction, but what can you do? Okay, so according to Buchanan and then to Locke, the rational voter will always go for a decision with that to minimize its expected cost, okay, of the social choice process. And the expected cost is grouped into two: is the expected external cost and then the expected decision making cost. As I said, the expected external cost, that one we are talking about the cost that a voter will incur because of the decisions of the other voters or the activities that the other voters engage themselves in. So we just find the present value of all the expected costs that the cost that you are expecting to incur as a result of the decisions that the other people have made. So what we need to understand is that the external cost is negatively related to the number of voters. So the higher the voters, the lower the external cost, then the lower the voters, the higher the external cost. But then the decision-making costs, okay, these ones are the costs that are incurred by the voter during the decision-making process. For example, maybe you are in Kofodia, you have to go and vote in Accra, transportation cost, the time that you are using. Okay, so whatever cost that you incur whilst you are engaging in the process is what we call the decision-making cost. Okay, the decision-making cost. But this one, there's a positive relationship between this cost and then the number of voters. For example, if you have a lot of people voting for a decision, the queue you have to join before you can cast your vote won't be a shorter queue. Okay, you have to stay there for a very long time. So you spend a lot of time there, making the decision making cost very large. Okay. Now, this is the external cost. The vertical one is the present value of the expected external cost, and then the horizontal one is the number of voters, the number of people that are required to make the decision. So you see the inverse relationship. As the number of people are increasing, then there's a reduction in the present value of the expected external cost. And then this is for the decision cost. Decision cost is positively related to the number of people that are engaged in the voting process. So this is it. This is the decision cost. This is the decision cost. Now, when we combine the two, okay, this is the external cost. This is the decision-making cost. So when we combine the two, the middle here, okay, this is the middle here, and this point here gives us the K star. And what do we use the K star for? The K star will minimize the persons or the voters or the individuals' present value of the total expected cost. So if you are able to get K star people, okay, if you get K star people to actually engage in the decision making process, then that will minimize the person's present value of the total expected cost. Okay. Now, if we are using K star to be the number of people, that will at least minimize the person's voting cost. Then we need at least K star over N of the population. This number of people must agree before we can actually take a collective action. Okay. Now we want to minimize whatever cost that we incur during the the decision-making process. Okay, the political voting process. So as the individual is trying to engage in this, the person is as well thinking about the cost that he has to incur. Okay, so he's looking for, an optimum number of voters that will actually be able to minimize whatever external costs that he or she will incur. Okay, so now what this means is that any voting rule will need a minimum of K star over N of the entire population to agree before a collective action or decision can be taken, so that they can minimize the total cost of collective decision making. So at least we need K star over N, okay, K star over N, okay, or K star out of the total population. Okay. So if you have more than K star, when you have more than K star, then you will be increasing the external cost. If you have less than, now, if you look at this, okay, if you look at this, this is this point here will give you the lowest of the total cost for the political process. Now we are combining both the external and then the decision-making cost. We've added the two, and this is the point where we get the lowest, the minimum. Okay. Now, if you move past K star, then you see that there's going to be an increase in the total cost. Okay. So at least let's just get K star out of the total population before we can actually minimize this cost. Okay. All right. So this is the end of the public choice theory.